So far we have understood the different building blocks, different technologies about IoT, how to build IoT using different technologies. We have already gone through in the different lectures. So we need to now understand that the IoT systems as a whole, comprising of devices such as different sensors, actuators and different other communication devices like Wi-Fi, 3G, 4G and so on. We have mobile devices. So, all of these in the IoT world, they are huge producers of data. So, IoT is heavily data intensive. It is heavily data intensive. So, lot of data gets produced in the IoT deployments, in the IoT implementation. So, these data have to be, number one, properly handled, and number two is they have to be analyzed to make sense out of the data, so that things can be made much more efficient. Wherever the IoT solutions are deployed, those problems can be solved, can be addressed much more efficiently. So, this is the requirement of the data analytics. So, we have two things being discussed in this lecture. Number one, how to handle the data handling, and number two is the data that is generated and is received may be collected at a server, either in a centralized way or maybe it can be distributed. The data can be collected in a distributed fashion. So, that data has to be analyzed to make sense out of it, to make things better. So, this is what we are going to look at. So, what are the subtleties, what are the important issues concerning this thing. So, this is what we have to understand, and this is what we are focusing on in this particular lecture. So, this is divided into data handling and analytics is divided into two parts. However, in both of these lectures, what we are going to do is we are simply trying to motivate ourselves and try to understand, because this is a introductory course on Internet of Things. Here we are not going to understand about the different methodologies for data handling. We can or how to perform the handling of the data, or how to analyze the data, that we are not going to understand in detail. We are simply going to understand that what are the tools, the methodology that are out there that can be used for handling and analysis of the data. So, we start with data handling. Data handling basically ensures that the data is stored properly, archived properly and disposed of in a safe and secure manner during and after the conclusion of the project. So, I am talking about a project in general in order to understand data handling. So, here we are considering the development of the policies and the procedures about how to handle the data electronically as well as through non-electronic means. So, in the IoT sphere, most of the data have certain features which are analogous to the features of big data. In other words, we are talking about IoT systems producing big data, and what is big data, that we will understand later, but for now we will just conceive of big data as data that is extraordinarily big in different ways, and what are those different ways, that we will see later on. So, due to heavy traffic generated by these IoT devices, there is huge amount of data that is created by the different sensors and the different other IoT devices. Huge amount of data is generated, and that data, it is big in size, continuously big streams of data flow through the network. So, are generated in the network. For example, if there is a camera that is fitted, so that camera basically streams in lot of data continuously. So, in a particular hour, when the camera stream data is collected, that is huge in size, and we are talking about not just 1 or 2 hours, but we are talking about collecting lot of data over days and months and years and so on. So, that data has to be number 1 stored, number 2 analyzed, and then how you are going to handle, as long as it is not required, after that it is no longer required, how you are going to dispose of that particular data. So, all these things have to be taken into consideration when we are planning or we are designing an IoT system. So, I was mentioning to you about big data. So, big data, there are different definitions of big data. So, one of these definitions says that big data technologies describe a new generation of technologies and architectures designed to economically extract value from very large volumes of a very wide variety of data by enabling high velocity capture, discovery and or analysis. So, big data shall mean that the data of which the volume, acquisition speed or data representation limits the capacity of using traditional relational methods to conduct effective analysis, or the data which may be effectively processed with important horizontal zoom technologies. So, what it means, all these fancy words have been used in these definitions. So, what it means, two things: data that is huge in size, that flows in large velocities, that is generated and disseminated in large velocities, have to be handled in real time. This is one issue. Second issue is these data are typically unstructured. They are typically unstructured. For example, text, huge text, Facebook data, Twitter data, all the social network data, or the data that are generated from the telescopes, the sky monitoring telescopes, the data that are generated from YouTube and so on. So, these have characteristics which are unstructured. They cannot be stored using traditional relational database technologies. So, how do you handle such data? So, this is a big concern in big data. So, that has to be taken care of. So, we cannot simply be concerned about simply deploying a network without being concerned about how to handle the data that this network is going to produce. That is why data handling and big data handling is important. So, we have, as I was telling you earlier, broadly two categories of data: structured data, like what we have been using, library information system, student information system, accounting information system. These are good examples of structured data. So, these data are easily organized, they can be stored in relational databases, relational tables. You can perform different queries on these data that are stored in the tables. And however, these type of structured data accounts for only 20% of the total available data in the world today, and definitely it is a very small amount of data in the IoT systems. So, IoT systems produce mostly unstructured data which cannot be stored in the form of relational tables. So, they do not abide by any predefined relational model for the storing of the data. Traditional RDBMS techniques are unusable, and these data, they are very huge in size. And most of the data, more than 80% of the total data that is available in the world today are in the unstructured form. Text feeds, video, audio, speech, YouTube data, telescope data, all these are good examples of unstructured data. Even the data that are produced from most of the IoT devices are unstructured. Most of the sensor data are unstructured. Cameras produce unstructured data. So, how do you handle this data? So, some of these characteristics of big data, earlier it started with the 3V, then came the 5V definition, and now people are talking about 7Vs. of big data. So, what are these V's? Number 1, volume. Number 2, V is velocity. Number 3 is variety. Number 4, variability. Number 5, veracity. Number 6, visualization, and number 7, value. So, these are the 7 different characteristics in the form of V's of big data. So, let us look at each of them one by one. So, volume. So, big data are characterized with large volumes of data, and the quantity of the data that is generated is huge in volume. We are talking about more than terabytes of data, several terabytes of data, of images, video, and so on and so forth. YouTube, YouTube basically, in every minute, in the YouTube 72 hours of video are uploaded. So, it is a huge amount of data, huge in terms of volume. So, this has to be in every minute. If it is so much, then just imagine that how much it is going to be every day, and in a year how much it is going to be. Velocity, as the name suggests, it concerns the speed of generation of the data. So, data processing time is decreasing day by day in order to produce real time services. Older batch processing technology is unable to handle high velocity of data. So, we need new technologies to handle this high velocity of data. So, these IoT devices, mobile phones, sensors, and so on, in huge speeds, high rate the data is being generated. For example, with respect to velocity, 140 million tweets are generated per day on average. The New York Stock Exchange captures 1 terabyte of trade information during each trading session. So, just imagine that how much data at what speed is generated in the IoT world. Variety refers to the category to which the data belongs, and most of the data are either unstructured or they are semi-structured. And examples could be, variety could be that pure text data, images, audio, video, web, GPS, then sensor data, SMS, documents, PDFs, flash, etc., etc. So, all these different varieties of data flowing through a single pipe in the IoT world, single pipe, huge amounts of data, huge volumes of data at high velocities, data which is highly varied, not only consisting of text, but text, audio, video, images, web, sensor, and so on. So, everything flowing together. Then we have variability, which refers to the data whose meaning is constantly changing. The meaning of the data constantly changes depending on the context. So, examples could be language processing. So, language, it is context dependent. So, sometimes language processing, it is context dependent. So, the meaning basically varies with context. Hashtags, geospatial data, multimedia, sensor events, and so on. Veracity refers to the biases, noise, abnormality that exists in the data. So, the IoT data that is typically generated is highly veracious. So, it is important in programs that involve automated decision making or feeding the data into an unsupervised machine learning algorithm. Veracity is not just about data quality, it is also about understanding the data. Visualization concerns how to present the data pictorially or in a particular easily understandable format. It enables the decision makers to see the analytics that are presented visually and identify new patterns. Value basically means that extracting useful business information from the scattered info. So, how much value the data has from the variety, so from the data, from the raw form, how much value it has. It includes a large volume and variety of data. It is easy to access and deliver quality analytics that enables informed decisions. There are different data handling technologies that are available for use. Cloud is one such popular technology. So, here in cloud basically has some of the essential characteristics as per the definition of NIST: on demand self service, broad network access, resource pooling, rapid elasticity, measured service. Measured service means what? Depending on the amounts of computational resources that are used, I will be billed accordingly. Rapid elasticity means if I need more resources, the resources are going to be made available through a pooling based mechanism. So, resources are going to be pooled from different physical devices, and I do not have to own these resources, this infrastructure I do not have to own, but I can still get access to these on an on demand manner depending on my requirement, and I will be billed accordingly. So, some of these basic service models that are there, and some of which we have already covered, include infrastructure as a service, platform as a service, and software as a service. So, cloud with these three basic service models, IaaS, PaaS and SaaS, is a very important data handling technology that is available to us. Second is Internet of Things. So, in the IoT world, the sensors that are embedded to the different devices and machines, they generate lot of data. The sensors transmit this sense data to remote servers via the internet, and these data, they can be either handled at the back end, or this data can also be processed locally at the edge or in the interim somewhere in the intermediate layer. So, continuous data acquisition from mobile equipment, transportation facilities, public facilities and home appliances are an important characteristic of IoT, and the data that is handled, data that is generated in the IoT have to be handled accordingly. Data centers basically concern storing lot of data, managing the data, organizing the data. These data that are generated in the data centers, that exist in the data centers, they have to be replicated, they have to be backed up, they provide sufficient network, sufficient network infrastructure has to be provided in order to handle this data, and these data, they can be analyzed in order to discover problems in the business operations. So, this is how the data flows from generation to analysis. So, first the data is generated, then comes acquisition of the data, storage of the data, and finally analysis of the data. So, in terms of generation of the data, from enterprise systems data can be generated, from IoT systems, from biomedical devices and different other devices, all of which are good sources or generators of data. In terms of acquisition, after the data generation, acquisition of the data are collected, data can be transported, data are pre-processed, and then data have to be stored. We have different technologies for doing it. We have the Hadoop technology for storage of data, MapReduce, NoSQL databases, and finally they have to be analyzed. So, for this we have the Bloom filter, parallel computing technologies, hashing mechanisms, indexing mechanisms and so on. The different sources of data include enterprise data, IoT data, biomedical data and other field data from computational biology, from nuclear research, from astronomy and so on. Now comes the data acquisition, which concerns data collection from log files, from different other records, activities, interviewing if required, collecting data from the sensors, from the sound sensors, voice, vibration, automobile, chemical, current, weather, pressure, temperature, etc. and so on. So, after the data are collected, they have to be transmitted. So, after collecting the data have to be transferred to a storage system for further processing and analysis. So, data transmission can be categorized as inter data center network transmission and intra data center network transmission. Then the data have to be pre-processed. These collected data suffer from noise, redundancy, inconsistency, etc. So, these have to be removed, they have to be pre-processed, the data have to be pre-processed. The pre-processing of the relational data mainly follows integration, cleaning and redundancy mitigation. Integration is combining the data from various sources and providing users with a uniform view of the data. Cleaning of the data is required in order to remove inaccuracies, incompleteness and unreasonable behavior of the data, unreasonable characteristics of the data, and then either modifying the data or to remove these problems or deleting this data altogether. Now, the data after acquisition, the data has to be stored. The data can be stored in the file systems or in databases. So, if we are talking about relational databases, SQL is good enough. However, with the kind of data that is exhibited, the unstructured data that is exhibited, this NoSQL is very useful. NoSQL basically uses three different types of databases. One is the key value database, the second is the column oriented database, and the third is the document oriented database. So, this is about the data handling, the different aspects of data handling. Now, for this, what technology do we have for handling this kind of data? What technology do we have? We have the Hadoop technology. So, what is Hadoop? This is basically a software framework for distributed processing of large data sets across large clusters of computers. It is an open source implementation for Google's GFS and MapReduce. GFS is basically the Google file system and MapReduce. Apache Hadoop's MapReduce and Hadoop distributed file system, which in short is called is well known as HDFS, has different components which are originally derived respectively from GFS, Google's MapReduce, and GFS, Google file system. So, these are the building blocks of Hadoop: Hadoop Common, HDFS, Hadoop distributed file system, MapReduce, and YARN, which stands for yet another resource negotiator. So, without going through each of these in further detail, we will just look at only HDFS, the Hadoop distributed file system. So, in HDFS, which is basically the most important thing in Hadoop. So, in HDFS there are two different types of nodes. We have the name node and we have the data node. So, the name node is a centralized node which maintains the metadata information about the different files storing the data, and the data node is a distributed node that stores the actual data in the form of files, which are again divided into blocks, and each of these blocks is replicated, and this is what is shown over here in this particular figure. So, what we see over here are these data nodes with replication of the blocks, and this is the name node. So, name node has the metadata and the data nodes have the actual data, and these data nodes are fragmented into blocks, and these blocks are replicated, and consequently we have more reliability in the storage of the data in Hadoop HDFS. So, we have the name node which stores the file system metadata and the data node which stores the actual data. Now, we also have these job and job trackers. The job tracker basically runs with the name node. It receives the user's job and decides on how many tasks will run. And the job tracker basically runs on each data node, receives the task from the job tracker, and it is always in communication with the job tracker, reporting it the progress that is made. So, as we can see over here, we have the job tracker and these different tasks which are monitored through the task tracker. So, we have the job tracker running on the name node and the task tracker which is running on the data nodes. So, here what we see is the master slave architecture in Hadoop. So, we have this kind of thing, we have the name node like this which contains the metadata, the name node, and then we have these different data nodes. This name node has the job tracker and the name node information, and this name node basically points to the data node of the data node in the data node that is installed, right. And then we have the map reduce. So, what we have, the task tracker is basically linked with the job tracker and the task tracker. So, job tracker in the name node is related to is linked with the task tracker in the data node. So, the job tracker resides in the map reduce layer, the name node in the HDFS layer, task tracker in the map reduce layer, data node in the HDFS layer, and so on. So, this is the architecture, the master slave architecture in Hadoop. So, with this we come to an end of the discussions on the file handling, and particularly focusing on file handling of this lecture on file handling and data analysis. And here some of these references are there, and with this we come to an end. And so, what we have discussed is how data handling is important, what are the different sources of data, how data have to be handled, and how Hadoop and its different components can come as an aid for handling data which has the features of big data that is generated from the IoT systems, how it can be how Hadoop can be used in order to handle this kind of data. Thank you.